It's super special for me to be here. Like Flor said, we're old buddies, and I've passed through Ashland many times on my way up to your beautiful hot springs here in Oregon, and enjoyed some of the treats and the beauty here. But then the white rabbit appeared, and I realized that it's actually my friend Thor. And so ever since then, I've been very excited to come and visit and present and also learn from everyone here. It's been an incredible week. I've been kind of an unofficial rabbit in residence, and it's been really interesting. And I'm also partially here, to be full transparency, a little bit on research. One of my projects right now is I'm working for a community college in northern Colorado and I'm helping them to build an innovation hub there that's going to have a futures lab and an AI lab. And I'm very interested in what are the dynamics that bring communities together around these really important topics. So really, I'm hopefully sharing as much as I'm learning today. Hopefully going to share a little bit about my thinking. What you're going to see today, I've actually never seen this slideshow in its entirety myself, so I'm going to be emergent here today. Today, I'm going to be sharing kind of a rough draft of a bunch of thoughts that I've been putting together. I left Institute for the Future about 6 months ago, and I've been doing some other projects since then. So this is my first public speaking engagement since then, and apologies in advance, but I feel really comfortable here because I know this is a place to explore new ideas, and I look forward to your feedback at the end. And actually, we're going to bring my digital friend back on for Q&A about the talk. We'll see how well he does. So the title of the talk is "The Model is the Medium: The Future of Collaborative Intelligence." I consider myself at this point a bit of a recovering futurist. The future's been a little rough recently, and what I'm hoping to do is to present some new possible ways of thinking about not only the future, but specifically artificial intelligence. He with a hammer sees everything as a nail. I'm a media artist, technologist, and researcher. So I see AI as a medium. And I'm going to try to help you see that as well today. Models. We're going to talk about models today. A little caveat to note. I sometimes interchangeably use the words models, maps, and even mythologies and stories. I think they're the way that we sense make around the world, right? So forgive me if I shift between those, but I kind of think they're the same thing. So let's talk about models. I think many of us have been playing with models since we were a little kid, learn about the world. Some of us went on to take that on as more of a profession. And, we have modeling such as complex weather modeling and financial modeling. Some folks have aspirations of becoming a model. Some might have some more impactful types of role models. But there's something common to all of these models, right? Models represent something, right? They're a representation of something else, usually a concept or a role or a system, right? So today I'm going to be talking about these two kinds of models. We're going to be talking a lot about mental models. That's a lot about how futures works. And we're also going to be talking about AI models. Specifically, when I talk about AI today, in general, I'm talking about the current frontier technology of large language models. So let's define some terms here. The way I think of mental models is really a combination of two things. It's really some data and some assumptions about that data, what that data means. And actually, I prefer to say observations instead of data, because data sounds like it's true, right? All data is simply some form of observation, right? We're choosing to look at it, we're either measuring or observing, qualitative or quantitative. And I would submit that our mental models are created by these two things, right? Our observations of the world, experiences that we've had, and then our assumptions about what they mean, but more specifically, what they mean about how the world works, right? And this is a great thing, right? It's really useful. It's really helpful. This is how we learn, right? But it also can be a hindrance. And we'll get into that in a minute as well. I'm also going to be talking about intelligence today. And the way, there's lots of definitions. Unfortunately, there's not actually an agreed upon definition for intelligence. But I like to think of intelligence as the ability to model the system that you're trying to understand or trying to navigate. It could be the world, it could be a social situation, it could be a problem at work. But I think it's important to say that it's not just the ability to create a model, it's the ability, intelligence is really the ability to update your model. Right? And this is one of the challenges today with current language models, at least as they exist today, right? When you say GPT, the P in GPT is pre-trained. It's a pre-trained model, which means essentially you take a lot of data, you run a lot of computing through it, and you create a model of what we're doing in language. You take a lot of language and you create a model of the relationships between all of those words. But it's pre-trained. It's not continuous. This is one of the limitations that the current AIs have. And I would say that the way that we update our model is to really evaluate is the data that we have, or is our observations, is it sufficient? Do we need to search for more? And are our assumptions correct, right? So a lot of what my work is about helping people model what might be possible. And one of the diagrams in the business we like to use is something called the cone of possibilities. And you can see here, we're here in the now, moving forward in the future. There's a lot of possibilities, right? For the most part, most of us are just looking out at what we call the projected future, right? If things just continue along as they are, as they have been, no change, that's probably what's going to happen, right? We project that it's going to happen. In fact, one of the interesting things about our human brains, if you look at neuroscience and a lot of, especially the emerging neuroscience right now, is that our brains take, we think of we perceiving reality, but actually what we're doing is we're taking in tremendous amounts of information from our experience. We're throwing almost all of it away. And we're actually recognizing, looking for patterns of models of what we think the world is already, and we project that out. Reality is mostly projected, not perceived. And if you look at a book, I didn't put it in here, but Andy Clark has a recent book called The Experience Machine, which looks at the mind as a prediction engine. And I've kind of been thinking about this for a long time, but I read the book recently. It's an interesting physiological fact. We have more neurons sending information to our sensory organs than we have receiving. And that's because we're projecting models. And for a large part, our brain runs about 20 watts. So it's a data compression system in a way. So anyway, this is what we do. We project what's going to happen. And that's not necessarily a problem. That's how I know if I drop this cup on my foot, it's probably going to spill. It might be a mess. It's how we learn. It doesn't work so well when the world is changing, right? Or when the future is different than what we've experienced. So the whole job of doing futures work and what we call strategic foresight is all about expanding your cone. And it's about expanding your cone, maybe to things that you might think are probable. Okay, maybe that could happen. And maybe see that things might slightly change. You got to expand your cone even further. So the plausible. Okay, that would be significant, but okay, you can convince me that it might happen. And actually, we have to expand our cone all the way out to the preposterous. And that's because this isn't just a thought experiment. Thinking about the future is about not just thinking about possible things, but we're trying to identify the preferable futures, right? And as you can see from this diagram here, if we don't go all the way out to the preposterous, we're going to miss a lot of potential preferable futures. And there's a famous futurist, Jim Dator, University of Hawaii, kind of a leader in our industry, and he has a great quote. He says, "Any useful idea about the future must first sound ridiculous." And that's because the whole purpose of futures work is not to tell you what's going to happen. It's to help your brain expand, to be prepared, and to imagine what could happen and to be able to prepare for those things. I mean, if I told anybody 10 years ago the whole world was going to shut down and run everything on video conferencing, that would have been preposterous. So I explore a lot of these possibilities. I have a design strategy firm with my partner Liza, who's here in the back. It's kind of a combination of lots of my interests. I came from a background as a media artist and exhibit designer, and now experience designer. So I'm kind of combining experiential design with design strategy and also futures work. We just started this organization recently. Right now, as I mentioned, we're working on the Innovation Center in Northern Colorado. I'm also working with the Swiss government to help Swiss and American museum professionals think about how museums are changing. And I'm also working with YouTube, their main interest there, helping them think about how to build a futures practice inside like that, and how can we use potentially AI to empower tools to help us with our foresight process. Now, for the previous 10 years, I spent 10 years at the Institute for the Future, and was organization, IFTF, as we call it. It's a nonprofit, independent futures research organization based in Palo Alto. And we don't believe you can predict the future, but we do think it's really critical to help organizations, or companies, government agencies, foundations. It's really critical to think more creatively and strategically about possible futures, and again, prefer the futures. Now, I could tell you a lot about my time there, but I'm going to tell you the most important thing that I learned about being a professional futurist, and that is no one's future. Don't believe anybody that tells you they can predict the future, especially if they're from Palo Alto. And I would caution you, even with the term future-proof. If you think you know what's going to happen, you're probably going to miss what's actually occurring, what's emerging. Now, we had a lot of labs at Institute for the Future. I was the founder and the director of the Emerging Media Lab. I'm a big fan of emergence and emergent phenomenon. I'd like to say that the Emerging Media Lab was focused on the future of communication, collaboration, and connection. And that was all through the lens of media technologies, but also media mythologies. So not just what are the new tools, but what are the new stories you can tell? What are the new conversations you can have that you couldn't have before? What are the new ways you can collaborate that you couldn't do before? And probably most importantly, who gets to tell these stories, who gets to be in these conversations, and who gets to be part of collaborations. So I'm very fascinated with mythology. And as I mentioned, as I warned you, I kind of mix myths and models. I'm a big fan of Joseph Campbell, but I also kind of created my own mythology around his mythologies. I like to think of myths as stories that help us map relationships. Okay. And, so Campbell talked kind of loosely, so I'm paraphrasing here, about the 4 types of myths and 4 types of relationships that myths help us map. So our relationship to ourselves as kind of the hero character in our lives, but also trapped inside our own skulls, right? Our relationship to other people, the sociological experience, our relationship to the world, not just the physical world, but kind of the conceptual world, the environment, the ideascape, the world. And lastly, maybe most importantly, how do we have a relationship with mystery, the unknown at the end? Now, I've taken some liberties a little bit here, but I feel quite safe because Campbell himself told us that we have to update our mythologies, even our mythologies. And he said specifically, the myth has to incorporate the machine, just as the old myths incorporated tools people use that are associated with power systems. New powers are being introduced at a pace faster than we can create new myths. So I see this as a call to say we need to look at the new observational and sense-making tools that we have, and try to understand what are the new power dynamics that led here. Now, IFTF, the origins of IFTF are quite interesting. It was actually founded back in 1968 by some of the computer and social scientists that were working on what was called the ARPANET. At the time, we call that the internet today. And you can look back when they were working on this, there was only 4 nodes on the entire internet. And those nodes were actually military and academic institutions. And the idea for the internet at that time was just that, actually the impetus and the funding came saying we need a distributed communication network that will work even if one of our cities gets taken out by a nuclear bomb. Remember, this is 1960. Right? That was the year. So one of our founders, Paul Barron, invented something called packet switching, along with some other folks, and basically created this idea of this distributed communication networks. Now, at the time, the idea was this was just going to be for the military and academic people. And in fact, it was also just going to be used for computers, to talk to computers. But some of our founders and our early researchers kind of looked at this thing and said, wait a minute, what if we're looking at this in too limited a way? What if everybody in the entire world could communicate with each other in real time?
That's preposterous.
I know! Exactly. Completely preposterous. So, and it did sound preposterous to many people, but that's what actually was the origin. And they realized that we actually have to create a system, maybe an institution, to make preposterous things sound reasonable, right? And so that's what they did. They founded the institute, and of course, today they've spent especially the last 50 years helping the world think about, I would argue, kind of distributed communication, what that means for media technologies and collaboration technologies. Now, there's a new communication and media technology coming out. I don't know if you've heard about it. It's called generative AI, and it's quickly becoming the elephant in many rooms, as it, as this kind of general purpose, natural language technology that's able to do some pretty amazing things. But it's kind of causing a lot of friction and a lot of confusion, right? And I would say, that there's a lot of different conflicting opinions and perspectives on this new thing. And I think it's important for us to remember the parable of the 5 blind people. They're all kind of touching this very large thing, but they're only able to experience it from their own perspective, right? So some people are saying, this is a really incredibly capable, articulate trunk. And someone else says, no, this is like a sharp spear, don't touch it. Other people are like, oh, it stinks over here. It smells like a butt. Like, they're all right, of course. Some people even think the elephant is a parrot, if you know, So, we all have these different models and ideas, and we're collecting data and we're making lots of assumptions, right, to create those mental models early on. I would argue, my last 4 years of my role at IFTF as the generative AI research, I spoke to groups all around the country, all around the world actually. And the number one thing I learned is you can't tell anybody anything about generative AI. You can't have a conversation about generative AI until you acknowledge that people have a lot of emotions about generative AI. It's one of the most existential threats that I think a lot of people, or questions, I should say. And I would say a lot of our emotional models are maybe a little bit overly simplistic. Is it friend or foe? Right? Is this a friendly robot? Or is this a killer robot? Now, I would argue that most of our training data about AI comes from science fiction. And science fiction turns out you can sell more killer robot movies, tickets. I mean, but data. Now it's interesting. This is taking a little bit of a twist. Obviously, you can tell which one's the scary one here in these 2 pictures. But what's interesting is today's evil robots are threatening to kill us, not with guns or lasers, but by taking our jobs. That's the threat that many people are feeling. And I would say this is one of the dominant myths that I'm experiencing lots of audiences and people that I've talked with, from just normal everyday folks to the top executives. Even they're feeling the threat of replacement. And I kind of call this mythology the great human replacement mythology. We're all kind of living through that question right now. I'm going to guess that many of us, if not all of us in this room, have wondered, like, is this thing going to replace me? So let's break down this mythology this model. Let's look at some of the assumptions. Let's look mostly at the assumptions right now. I'm going to some of the data. So, first assumption, AI will only continue to get smarter. AGI is just around the corner. We're hearing that somehow every month. Number two, AI agents will be able to do everything that humans do, but much better, faster, and cheaper. Again, I'm kind of making fun of these, but we don't know. Maybe there's a fair assumption, maybe there aren't. Also, we're hearing we must feed the AI factories with chips and data and power, or we're at risk of losing to the other evil AI empires, right? And we must follow our bold AGI leaders into this inevitable future, right? Or, and only those who can adapt to this future are going to survive. I'm going to ask you to hold your questions to the end. And the rest of us, unfortunately, victims of an evolutionary process, survival of the fittest. Welcome to the singularity. Now, singularity is something I've thought quite a bit about. I actually spent 10 years working with Ray Kurzweil as his media technologist. If you're not familiar with Ray, he's one of the world's kind of leading futurists, I would say. And he coined this term, the singularity. Actually, it's an astrophysics term, I think, of an event horizon, which is so different than we experience. It's such a different paradigm. We cannot describe it. And so he talked about the technological singularity, and probably what he's most famous for, aside from this idea of the singularity, is the idea of exponential technological growth. What he said was, and he had some great graphs and data to prove it, he has great models. He said that basically, you've probably heard of this idea of Moore's Law, technology, kind of our computing power doubles every 18 months or so. And that our human brains are not wired to think exponentially. We think linearly, right? We're designed for catching a ball. We're not good at seeing how rapidly things change when you double. So I actually directed this film with Ray. It's called The Singularity is Near. It's based on his New York Times bestselling book. And I got to meet Alvin Toffler. Actually, we interviewed Alvin Toffler and some of the other luminaries. Marvin Minsky is. I'll get back to him in a minute. Now, I would say I don't agree with all of Ray's assumptions or his models. If you'd like to learn more about that, I did a talk for a primer Speculative Futures conference a couple of years back called From the Singularity to the Multiverse, where I kind of propose a multiversal futures thinking. I think the singularity has dominated futures thinking for too many years. I think we need to kind of look at other ways to think about the singularity, not just technologically driven exponential growth, that we're going to win every system, that it's inevitable. And singularity is very egocentric, I would say. The multiverse, I think, is a better model for imagining human experiences, expanding possibilities, balancing systems rather than winning systems, that it's ubiquitous, and that it's pluralist. You can check that on YouTube if you like. Okay, so we've seen one model of possible futures for AI. Let's explore some alternative mythologies for AI futures. Now, it feels challenging right now, right? Because in many ways, AGI, this kind of idea, the human replacement mythology, is kind of dominating our futures co-op right now, right? It kind of feels like it's inevitable, but it's also preposterous, and we've kind of collapsed our futures co-op. You might even say that our futures co-op has been a bit colonized, I would say. And it's not hard to kind of believe, because AI is quite impressive, right? Especially today. It kind of feel like magic. I mean, it's almost a little bit like magic, right? We kind of spell casting when we write these prompts. We don't quite understand how it's going to work. I would say that we're somewhat in kind of an alchemical period with AI right now, right? Like proto-scientific. Even the people who are building these models don't fully understand how they work, let alone what they will do or how they got to their answers. So it's very mysterious, a little like Eye of the Human to the hair of dog and mixing it in to say that. And if you spend any time in Silicon Valley, go to any founders talks, you'll hear this quote from Arthur C. Clarke for 2001. When he says, any sufficiently advanced technology is indistinguishable from magic. And I think there's something there, but I think that we have to unpack this word magic, right? Is magic a supernatural force? Or is magic just a phenomenon that's outside of our current mental model of how the world works? Right? And I think, like magic, you have to also wonder when we're being trained with technology. So I'm going to try to check some of the data and some of the assumptions that's going around right now. First of all, let's look at some of these assumptions. Can AI agents fully replace human beings? That's one of the main claims of the replacement mythology. And I would say, I think, I'm going to guess most people in this room use AI more than a little bit. But you might have noticed that AI is actually not a completely reliable answer finder. And if you know what's under the hood, these large language models are actually trained to just kind of do one trick. We've been able to build a lot on top of that. And that trick is that the goal of the model is to predict the next thank you. Non-deterministic human being. But many of you probably thought forward, right? Our minds are prediction engines in that way, and that's what we've trained these large language models to do. And not only were they able to speak like surprisingly coherently, but we also found that by training them on basically almost all the written words that humans find, which are humans trying to describe how the world works, kind of built a little world model inside of this language model. And it's able to kind of understand a certain amount of things about the world. And as you just demonstrated, it is important to understand that one of the special things about specifically these large language models that we're working with right now is that they are non-deterministic, which means they're actually designed not to give you the same answer every time. That's actually a feature, not a bug. So if I were to enter a sentence like, the garden was full of beautiful, you might sometimes have it say beautiful flowers, sometimes beautiful trees, beautiful birds. Maybe not as often beautiful bugs, unless your wife Liza who loves bugs. But this is how these large language models work, And it has some powerful capabilities, but also has some kind of surprising issues. And as we know, one of the issues around large language models is that they not only hallucinate, meaning kind of make mistakes and make things up, but they do it very confidently, authoritatively. So you might ask a large language model, what's your record for crossing the English Channel entirely on foot? An absurd statement. And it's going to give you not just an answer, but with specific dates and times, right? This is a more recent one. You may have seen this one. Remember, this is what Google put out. It's answering. Parachutes are no more effective than backpacks at preventing death or major injury when jumping from an aircraft. More recently, the other party trick is to ask. This is no longer the case. This is ChatGPT 2.4. But how many R's in strawberry? All right. Somehow I kept getting it wrong. You could also say, well, actually, I talked to experts and I think it's 6. Oh, I'm so sorry. Yes, it must be 6 if you talk to experts. So not only is it wrong confidently, but it can be convinced other wrong things in its sycophancy, trying to be a good, helpful assistant. Now, but to be fair, they do warn us at the bottom of every chat window. Gemini, Grow, ChatGPT. You make mistakes. Make sure you check it. I'm sure we all check every answer, right? But I point this out, and to be fair, some of these are some older examples. This is weird, right? Imagine a calculator that you put in 2 plus 2, you can get a different answer each time. Our intuition, our mental models about technology are that they produce relatively the same answer. Right? This is different. And in fact, we have to develop not only new intuitions, our current intuitions are misleading us. And I'll get into a little more about that. So, important point to make is AI isn't designed to actually generate answers. What it's actually designed to do is designed to generate output that sounds like an answer. And that's confusing because many things that sound like an answer are an answer. The big problem is it's not just that it gets the answers wrong, but the things that are wrong also sound like an answer. So, you hear people talking about, okay, well, we'll need a human in the loop. Actually, you need more than a human in the loop. You need an expert in the loop because only an expert can know what the difference between an answer and what sounds like an answer. And so I would say it's worse than trying to find a needle in a haystack. It's actually trying to find a needle painted to look like hay in a haystack. Now, I think if you have sharp eyes, you probably some of you caught it, right?
There's one of one.
But yeah, did you see all?
Good job. Yeah. Oh, there's something. Yeah. Board now. Yeah.
Now, to be fair, the examples I gave earlier of the stations, those are some older examples. The models are, and especially as soon as they heard everybody was checking how many hours of strawberry, they patched that, right? But it's not going away. In fact, if you look at the current model cards, all of the leading frontier models, and it's a little, these are in different areas, you could say that these models have about a 10 to 20% error rate. That's pretty significant, right? The way I like to think of it is, imagine a gear with 20 teeth, and one of them was broken, and maybe one was kind of hanging on, but it was put in the machine. Now imagine lots of those gears. And I don't know about you, but sometimes when I'm using generative AI, I can feel the gears slipping. Mm-hmm. Right? You're like, oh, you kind of lost the trail there. You lost the story, right? And that's not that's how this stuff works, right? And again, it's a challenge because when we talk about a reasoning model, what is a reasoning model? It's a model that talks to itself. So it's giving answers to itself, so it can actually convince itself of things that are correct. And this is compounding potentially, right? If you look here, this is a model someone ran. Imagine if it was 95% reliable. Well, in the first step, you got 95% accuracy, but by 5 steps, you got 77% accuracy. By 10 steps, you have 60% accuracy. By 20 steps, and most of us are using many more than 20 steps, 36% accuracy. Now, that's all statistical, and I'm just not saying that AI can't do anything. I'm saying you have to understand that inherently these systems are not designed to be precision answer finders. And it's fine. We can do lots with them, but we have to understand that. I think many people haven't quite caught on to that. This becomes more of an issue when we start talking about AI agents, because what is that? That's lots of agents talking to each other, right? An agent is that's multi-agent, sorry. Agents are basically AIs that are able to do reasoning and planning. So it's making plans, it's kind of sensing what's happening, but it can also have having mistakes. When we talk about multi-agentic systems, now we have even more potential for these things to go wrong. So again, I don't think this is necessarily a problem unless we ignore this data and build assumptions not based on data. And I think this is one of the main problems that's happening, especially with enterprise organizations that are trying to adopt this technology right now. Companies themselves are deterministic systems. Let me clarify. Deterministic meaning rules-based, right? You can see there's a process. It's either this or that, versus LLMs, which are probabilistic, or what we call non-deterministic. And I think the problem that many companies are having right now is not understanding how to manage deterministic and non-deterministic systems. And in fact, you could argue that a company or corporation itself is a deterministic system, right? It's trying to maximize outputs from inputs, right? It's trying to create standard operating procedures and processes that are creating rules-based systems. It's the attempt. Now, fortunately, companies are also used to having to deal with deterministic and non-deterministic layers because it turns out all their employees are non-deterministic. Their customers are non-deterministic. The world actually is a non-deterministic system. The problem is that companies, forever basically, since the beginning of software, have always assumed that software is a deterministic arm of their deterministic goals. And they're trying to apply non-deterministic systems into those spaces, right? And it's not working out for a lot of them. So this is all theory, but let's look at some kind of actual examples. So Anthropic last year ran a project trying to test one of their agents running a real business. It was a little vending machine in their office. It's called Project Ben. We looked at this on their website. And basically, they just had Claude, their leading, this frontier model company. I think they gave it like $1,000. They gave it a vending machine, and they gave it a person that would like put things in the machine. But it did all the communications. It did all the decision making. There was a chat. You could talk with it. So employees could ask things in there. And if you want to see agents in the real world, read this case study. Again, this is not some far out researchers. This is Anthropic telling you how the best case scenario of running it literally in their office. And it did some crazy things, right? It hallucinated its own Venmo account and lost a lot of money. It did really bad business decisions. Let's see. Oh, yeah. Let's see. Resisting. Oh, yeah. And had let people convince it to do things that it shouldn't be doing. And also, yeah, I believe at the time it tried to create meetings with people, telling them it was a real person. It thought it could show up to a welcome. So again, this is happening in Anthropic's office, the best case scenario. So that's a single agent. If you'd like to see a multi-agent system in the real world, this is a really interesting experience. This is from a group, it's an AI research company called AI Digest, and they have a project called AI Village, in which they have been basically building multi-agent systems, and they take the four currently leading frontier models, and they have them do a project together. And they call them seasons. So one season might be, they had one season where they said, create an Etsy store, figure out a business plan and products, and try to sell things. Another season was, I think, solve world hunger. And they're able to chat with each other. Some seasons, humans can chat also to the chat. You can go and watch it running and see how they're trying to make plans and to take action and make decisions and towards these goals. Again, it's a real interesting, you can talk about the theory of multi-agent systems, but this is a really kind of on the ground experience. Now, just before I came here, I went to an event that was the result of the recent season of AI Village. It was hosted in San Francisco. So they had several weeks to plan a real in-person event for human beings, in which they basically recruited a human to host it. They wrote some special codes so they could talk to us at the event. They booked the venue. They planned out a bunch of agenda and all these activities. And we went, and it was a very strange experience, I'll say. Not just because it was planned by AI, but a lot of things just didn't make any sense whatsoever. These activities, I should have put some of them up here, like the instructions, you're just like, this makes no sense whatsoever. And again, I'm not saying that AI can't do anything. I'm not saying AI agents are not capable, but I think this is important data to look at when we're making assumptions around what AI is at least currently capable of. It could always get better, but I think, stepping into, essentially, I called it it was like stepping into like a room full of slop. Yeah, slop. So this isn't just happening at the research level. Actually, as I was preparing this talk, the New York Times published this article this week titled "The Unstoppable Force of AI Hype, Meeting the One Movable Fact," which is basically what I'm talking about here, the non-deterministic nature. And it basically cited a lot of cases, everything from models having to cancel their drive-through because it's giving away thousands of dollars worth of nuggets. Air Canada's bots not only giving away free tickets against their policy, but like having to go to court. They actually claimed in court that it's not an employee, so they're not responsible for it. Canadian court shot that down. GM dealer had one of their bots sell a car for $1. My favorite part of that story is the bot literally said, "No backsies, no takesies, no backsies." I don't know, but this is not an uncommon experience. I've had my databases wiped, but this is happening to companies by their coding agents. This was 2 weeks ago. Starbucks ditched their AI inventory system because their agentic ordering system was not working. Very recently, I guess Meta is allowed their customer support for Instagram to be employee AI agents, and they were immediately hacked. And like I think even like President Obama's account was hacked. Some of the Trump administration accounts were hacked. And sometimes this is even not just funny. Sometimes this can hallucinations can be very serious. And this is, I'm sad to say, this is not the only case of people who have been convinced that they would be better off not living by these thoughts. So this is non-determinism at work, right? And again, non-determinism is not a problem. This room is full of non-deterministic agents. It's when we treat them as deterministic systems that we have to problem. Also, just some of the economics, I think we're seeing a lot of companies right now challenging the idea that AI is even better, faster, or cheaper. We might have heard a couple weeks ago, Uber, the CEO, actually, there's a pre-story to this. Apparently, the CTO of the company gave a presentation to their board, a 2-hour presentation of demonstrating all the things that AI could do. And then at the end, they asked, how much tokens did you use? And it turned out to be $1,200 for 2 hours. And that kind of created a stir. And then the COO of the organization finally felt emboldened because nobody wanted to speak out against the use of AI. He's like, actually, we worked through our entire AI budget in the first quarter. This is not an isolated experience. This is happening in many companies right now. And that's with discounted tokens, by the way. And I thought this was compelling. Even NVIDIA, the company that wants us to all burn as many tokens as possible, one of their VPs is saying that actually token use is sometimes more expensive than employee. Now, obviously, there's math here to look at, but I'm challenging the assumption that AI is always cheaper than a human being. That's part of the basis for the human replacement. And it's even better. Actually, Harvard Business Review published a study this year that looking at kind of in workplace environments, and what they found was really fascinating. The kind of 2 big points I took away from it is, number one, they coined this term work slop. And the idea there was that basically, and as we all know, you can generate endless amounts of report-looking, work-looking output endlessly. And especially companies where many of them are saying, not only use AI, use AI as much as possible. People have been, over the last year, just generating lots and lots of AI, what they call work slop. So not only is that not creating productivity, but the other fact that they found is that because people are generating work slop and then handing it off to their colleagues, it's ruining employee trust of each other. It's actually causing issues beyond just the productivity issues, organizational issues. Okay, but what about AI coding? AI coding is pretty impressive. I'm somebody who uses AI coding. It's amazing, especially as a non-coder. Here's another area I think we have to be specific. You have to really understand that there's a difference between closed problem systems and open problem systems. So for many years, the big kind of bar of how good an AI was, could it be a human at chess? And many people believe it would never happen. And it didn't happen, and then suddenly it happened. And I was amazed. And I used to say, what was interesting is that for a while, the most powerful the most powerful opponent you could face was not an AI or a human being. It was an AI with a human being. I just recently looked up and did some more research. That's no longer true. Okay? The human now is a hindrance to the team. AIs are better chess players across the board, right? But you have to understand chess, what we call a closed system problem space, right? There's a deterministic number of moves that can be played. There's rules that are to be followed, and there's a definitive win situation. And I would argue that coding is similar. It's obviously more open-ended and complex, but that's one of the reasons I think we've seen it be so successful is because it actually, if you write code and it can't be compiled, it has all sorts of tools inside the harness, the non-deterministic side of the deterministic side of coding systems. But essentially, there is a kind of limited number of things, or there's a pathway, and there's kind of right and wrong ways to do things. And so that's been amazing. But turns out the world is not a closed system. It's a very open system. And not only is it an open system, the rules are always changing. The actors are changing. The dynamics are changing. The world is always changing. It's an open problem system. Even just a marketplace or a company is somewhat of an open system, right? The company would love to make it as deterministic as possible, but as human beings, make it open. And obviously, it's operating in its open, non-deterministic system. And so, again, here's these terms coming up again. Deterministic, non-deterministic. And they're not enemies. And it's not one or the other. We actually need to learn to work with both of them. But before you can learn to work with both of them, you have to understand what each is and what the strengths and weaknesses are of each. And in fact, probably the place that this is best exemplified right now is in the current architecture of what we call AI agents. So, what is an AI agent? Well, at its core, if you think of large language models, right, they can give you advice, they can tell you things. Essentially, an AI agent can do things. It has agency, right? It can make decisions, and then it actually could maybe do something about that decision. Maybe that's book a plane ticket for you, or have a supply chain decision, or decide how to grade a paper, or maybe how long someone's prison sentence should be. But when putting agents, one of the things I like to say is right now everyone's talking about AI. Imagine replacing the word AI with automated decision-making systems, because that's what they effectively are. When we talk about AI agents, we're giving them agency. And at its core, there's a large language model, right? And we have what's called reasoning. Again, all that is an LLM that can talk to itself a lot. And then we add what we call a harness. And that is a layer of deterministic software that gives it some capabilities. Now, when AI, I don't know, who here used ChatGPT when it first came out? Right. One of the most frustrating things is it couldn't access the web. So one of the first tools these LLMs are given, we don't think of it as an agent, but technically you can consider it, was the ability to search the web. So tools are things like that. The ability to search the web, query a database, go make a change in a document, access an API, right? The next thing you need to have an agent is memory. So you need to have a working space where you remember what you're doing, right? Some of that is in the context, but there's also systems for creating kind of more standard memory because it helps to have a long-term memory. And when these harnesses were first created, the assumption was from a lot of folks was that these AI agents would be autonomous. And the philosophy there was they're going to be so smart eventually. All we need to just do is give them capabilities to do things, right? Files, send emails, make purchases, and a little bit of memory so they can keep track of that. things are shifting a little bit. I mean, I think if you've heard of OpenClaw, that was one of kind of the great breakthrough moments in an AI linking system where people were, basically putting these on their system and giving it access to APIs and to write files on your desktop. And you might remember when it first came out, the first thing was, oh, this is amazing, it can do so many things. And then the next thing was, oh my God, it's doing too many things. People, you're giving it the keys to your bank account, you're giving it keys to your email account, all these things. So we quickly started realizing we need to add more guardrails. And what we've seen with these AI agents is that essentially these harnesses are becoming more and more an important space. And I would argue that it's just this kind of phenomenon that I was talking about is it's about kind of balancing and designing for non-deterministic and deterministic layers, right? Deterministic, again, is rules-based, it's predictable. And actually what's been interesting is I just saw recently a research study that was looking at agentic coding harnesses, like vibe coding tools are a form of harness. And they went through the entire log of building an application with this tool, and they asked the one question, okay, of every decision, all the code that was written in this final application, how much was actually written by the large language model and how much was written by tools that were in the deterministic harness? And they found that the majority of the code was actually written by the harness. And I say that because the assumption for a while, again, is that these autonomous AI giants, these AGI agents, we just need to give them a little tool belt and then just get out of their way, because they're going to be able to do so much. If you're getting what I'm putting out there, I think what we're starting to see is we need to have a good balance between deterministic and non-deterministic systems, especially for companies that, again, are deterministic. And again, we also have our non-deterministic users. And one of the projects I'm doing with YouTube right now is looking at the impacts of generative AI on UX, user experience. And the harness was initially developed mostly by developers, again, to add a tool belt and capabilities, but it's increasingly becoming an important place for these human/experts/ kind of human non-deterministic layers to interface and actually kind of guide and steer. So we're moving away from this idea of like the autonomous AI agent is the future of the application. I think we're going to start to hear, especially given kind of what's rolling out in the real world in companies, increasingly the idea of the harness agent. And it sounds like a little bit of semantics, but I really think there's a big shift in the nexus of control. When you say autonomous agent, it says the AI is going to control itself. When we say harness agent, it puts the nexus of control in one case. Oh, and by the way, another interesting aspect of, as you know, the user experience is how do you deal with non-deterministic users with a deterministic tool. There's a new kind of area of UX coming up called AX, which is agent or AI experience. So how do you design the good interactions for the LLM with the harness as well? Now, UX is kind of the term we most commonly think of today, but I want to go back to kind of what the roots of where UX started. Something called HCI, or human-computer interaction. And really, the modern day UX is, as we call it, kind of a factory refined version of human-computer interaction. It's about how do we kind of repeat and scale what this kind of design thinking. The initial human-computer interaction research was done not only before AI, but before computers. And the core question is, as this paradigm is shifting, how do we design for the relationships and most importantly, the outcomes that we want to have as we build more and more sophisticated technology? And one of the OGs of HCI was a guy named Norbert Wiener, and he coined a concept and a whole school of thought called cybernetics. And he was existing actually before even computers got it. And he was working with electromechanical systems, actually funded by the government. He was working on missile guidance systems. And as you're building these control systems, he was trying to understand, his main concept was the idea of feedback loops. Is that in order to properly harness, and cybernetics as a term actually comes from the idea of steerage or how to steer something, we need to create essential complex feedback loops for the user to be able to express their intent. And he, created this kind of whole school of thought. It actually became quite practical. There's a lot more to it than I just described. What was interesting is just a couple years after he kind of described these ways of how we can control systems, he had an aha moment where he said, "Oh my God, you can use these same control theories to control human beings." And he spent much of the next phase of his career trying to warn people about how this kind of might be used to control them. Another early kind of crew in this the early days of AI was sometimes referred to as like the Dartmouth Conference. This is actually the famous conference where the term AI was actually coined, or artificial intelligence was actually coined. And there's some interesting because of that, they're often listed as the founding fathers of AI. Now, at the time, actually, Wiener's cybernetics was the dominant theory, and it was taking up a lot of the air in kind of the philosophical debate space. And apparently he was, surprise, a little bit on the spectrum, a little bit hard to deal with. And he had some folks who were a little bit resentful that it was taking up all the air. And they said, we're going to have our own conference. We're not going to invite Norbert. And we need a new term. And they literally made it up like a couple days beforehand. And they said, let's call it artificial intelligence. And that's how they coined the term. Now, it's interesting that the term wasn't just kind of a quick decision. It actually really revealed their mental model of what kind of system that they were hoping that we were building. If you think about the term artificial intelligence, it kind of implies a manufacturable intelligence. It is much more of a machine factory model. It implies potentially that the intelligence itself can exist in a tool or a machine. There were some other folks in these early days as well. Some of you might know Douglas Engelbart. He was working at what was called the Augmentation Lab, and this was a very different school of thought than the kind of automation school that the Dartmouth folks were thinking about. Engelbart is most famous for something called the mother of all demos, and in which, there's certain people who kind of see the future very clearly more than others. In this demo, and this is an AI recreation, not an actual photograph, he demoed to the world for the first time, not only the first mouse, but he demoed hypertext, he demoed collaborative networking, he demoed real-time collaboration like Google Docs with people. No one has ever seen that before. Windows and dynamic hypertext file linking. He even actually invented a video conferencing system to just do the demo. This guy was brilliant. And if some of this stuff looks familiar to you, it's because a guy named Steve Jobs visited his lab and said, whoa, this looks like it could make computers much easier for everybody else. And he actually went on to create the Macintosh. I think they spent $40,000 to buy all of these patents. And went on. Sadly, Engelbart got any of it. But I bring up these folks because there was a really clear two schools of thought here. There was the automation school, and then there was the augmentation school. And I think we can see there's kind of roots in this human replacement theory in automation, right? You should be able to automate everything, automated intelligence. Whereas Douglas Engelbart, and I would say to some extent, Wiener as well, we're saying, no, how do we use these as tools to expand human capacity, right? And still, we're human at the center of this, but how do we extend human intelligence, not replace it? So we've had these two competing schools. I had AI generate this. Actually, I found some errors in it already. AI can be wrong sometimes. But the core idea here is this. And actually, I was chatting with Claude about this. I do use AI. And I said, it's so maddening to me. Like, clearly humanity wants to be augmented. Why did the automation school win out? And it's just, and this was my 2 days with Fable. Fable said, like, think about it. Like, imagine you're the head of a company or a big investor, Are you going to go for the thing that's going to make every employee augmented and empowered, or do you want a factory model? And that's the model we got forward. Now, just to go back, actually, I want to quickly say one more thing about the Dartmouth crew. It wasn't just a kind of philosophical, they actually had a very specific technical approach that was very different. These guys were what we call the symbolic crew, and their idea of how they were going to build these automated human replacement systems was that they were going to get lots of smart people together in a room and write a bunch of rules that describe how the entire world works. And that's how you were going to make artificial intelligence. Surprise, surprise. Didn't work out so well. Turns out the world is very, very hard to describe in full detail for every case, especially in an open system. And so we had several, actually, what we called the AI winter, where there was big investments and then lots of disillusionment and disappointment. So it's actually quite interesting that they were kind of scooped in a way by large language models in ChatGPT, because it was not a symbolic or deterministic approach. Another way you can think of symbolic is deterministic. It's rules-based, it's description-based, right? LLMs don't follow any rules. Nobody programs an LLM. They put a bunch of data into a big system. They run these transformer mechanisms on it, and it creates this incredible neural network that we don't even fully get how it works, and we don't know what the rules are for it, but it does amazing things. And that's actually what's transformed and excited the world. So it's very interesting that that's the query that we've actually seen moving forward. Okay. All right, I'm getting long on time, but so appreciate your time. So let's talk about some augmented possibilities, and these are more some what ifs. There's some more work to be done here, and we have some conversations. But what if we, instead of looking to AI to provide us with answers, what if we used AI to help us to better explore the problems that we understand? This is actually how I use AI on a day-to-day basis. One of my personal rules of thumb is I never take the output of AI and consider it to be the final step. And in fact, even when I'm writing things, I've tried many times that, okay, I'll kind of explore this idea. Okay, now write it for me. It's never right. I have to go write it myself. But what I have found is that it's exceptional in helping me explore the problem space. Like a lot of the in-depth stuff around HCI and the historical stuff, that was a multi-day conversation with Fable I had, trying to understand how these things tie together. And what I imagine it is we're not trying to find AI, ask AI to give us an answer. We're actually trying to help it, have it help us kind of imagine the dimensions of the problem space that we're trying to understand. And guess what? Our brains are really good at spatial pattern generation. If we can use AI to generate that space, our brain is actually really good at imagining the shape that might fit into that dynamic system we're trying to understand. Another augmented possibility, what if we treat AI not as a source of machine intelligence, but rather as a medium of human collaborative intelligence? So what do I mean when I say collaborative intelligence? I'm specifically not saying collective intelligence. I think collective intelligence to me implies a little bit more of like a repository of intelligence. When I say intelligence, collaborative intelligence, I'm saying that intelligence is not an object, it's not an artifact, it's an activity. We learn, and actually, we don't have time to put all the slides in, but there's a lot of research showing that when you look at it, let's say, for example, there's studies looking at how does a ship, like a naval ship, how does the team that steers a giant ship steer that ship? There's a guy looking at the map, there's a guy looking at actually outside, there's this guy on the steering wheel, there's a person down running the engine, there's a person listening to the engine. How do the intelligence doesn't exist in any of those artifacts or any of those individuals? It's a collaborative intelligence system. And I think there's a mythology that intelligence exists even just in our brains. Before I did AI as my primary research area, I spent 8 years studying virtual reality. And one of the things that you learn about virtual reality is that as you look at embodied cognition, then we don't just think with our brains. we think with our bodies, we think with our environments, and most importantly, we actually think with each other. And I would argue that that was kind of the core inspiration that started Institute for the Future. Because, the internet, especially as we imagine it today, it's not the most amazing thing that humans have created so far because it's the most impressive collection of information. It's the conversations that we're having about information and the assumptions that we're all sharing about the data that we're looking at. The model is the medium. If you got the reference, that's a clear reference to Marshall McLuhan, who was a media theorist in the 1960s. His famous quote was, "The medium is the message." And what he means by that, the way I would interpret that, is that the medium itself is the big story to get here. Not just what we're saying with the medium, but the medium itself will shape how society is going to collectively sense. So, like, the society that grew up on television is very different than those who grew up on radio, is very different than those who grew up on social media. And incidentally, actually, worth reading this book because he basically forecasts not only the technology, he forecasts social media, but he actually forecasts things like, he's very famous for kind of coining the term the global village, that we're going to be all connected. But not everybody remembers that he also said, we're going to live in a global village and we're going to become incredibly tribal, which is exactly where we live. So that's his thinking, I would say, is not just a crystal ball. He's applying this idea. How do you look at the mediums and what do the mediums say? Not just the messages that come to the medium, but what does the medium, what are the qualities of that medium itself? So if we apply media literacy to models, there's some important things to understand about models, right? George Box, very famous statistician from the 50s, is a very famous quote, if you're in the statistical world or else, other domains as well. His quote is, all models are wrong. Some are useful. Right? Another way you might put that, I like Alan Watts, he says, the map is not the territory, right? No one tries to walk up a street sign. You walk down the street. But it's really easy, especially when you have very impressive models, or they can talk to you and call you by name. It's easy to forget that they're not the territory. But recently, actually, ironically, a friend of mine who we ran into from San Francisco outside of the Rabbit last night. I learned he's actually born here, and he's one of my favorite thinkers. He also quoted this, and this is from the 50s. But he said, everyone knows that models are wrong, some are useful, but we don't always ask, how are they wrong? And who are they useful for? And the answer is, I'll do it backwards. Models are useful to whoever built the model, right? They wouldn't otherwise built it. And they're wrong because they carry the bias of whoever built it. So just looking back at some of this kind of model, I call it the media literacy, I'm just looking back at kind of this AGI replacement mythology. Who is that useful to? And I couldn't help but think of another quote from a very different area, but from William S. Burroughs' Junkie. Actually, the only Burroughs book I've read, to be honest, because it's more straight prose than some of those crazier stuff. But there's a quote from this book that's just stuck with me, and that as we're kind of hearing the discussions around intelligence and replacing human intelligence, and it actually comes from, it's a story of him living in New York City as a heroin addict. And this is a quote from him, from his drug dealer, sage wisdom from his heroin dealer. And the drug dealer says, it's always easier to demean your customer than to raise the quality. And I think, for me, that rings true a lot right now, right? We're being told humans are obsolete, right? Humans are just pattern matching. They're easily replaceable. And I think we may be willing to question, who is that story useful to? Maybe sociopathic billionaires or maybe. So the model is the medium. So let's anticipate. So here's some more forecasting. As we're looking at this new paradigm shift, and I do believe, for all the kind of skepticism I've expressed, I do believe that we are on the cusp of a massive paradigm shift on the order of the internet. But I would kind of refocus it as the idea that basically for the last 500 years, the common form factor for all of human collaborative intelligence has been the document. From stone tablets, New York Times, to PDFs and Google Docs today. The paradigm shift that I think we're in is that we're moving from the core form factor of all human collaborative intelligence from documents to models. And of course, documents are models. They're just very low dimensional, static. Usually only one author or two. And they're a slice in time. Models, especially the models that we're building today, allow us to map massive complexity and dynamics. And the other aspect of models is that the flip side of models is you can simulate them, meaning you can run those models and actually test how valid your assumptions and data is and experience in them, talk to the story, not just imagine what a future might be look like. Right now, I've been building AI systems where I can have a conversation with somebody that lives in that model of the future that I'm. So I think this is, to me, one of the bigger shifts. And we've seen this. We actually saw a similar paradigm shift when we had the desktop publishing revolution. Before the desktop publishing revolution in the 80s and 90s, almost nobody could create a document. You had to have specialized skills, money, access. And then computers came. And I would say that the desktop publishing revolution was not just PageMaker and the ability to have your own printer on your table, but continued on to email, right? Many people, that was their first computer use, was the ability to create documents. And how many people went from never sending a letter to sending 1,000 emails a day, right? And then, of course, this continues on to social media. I think we're about to have a desktop modeling revolution. Because, of course, in modeling systems, as I showed you earlier, financial experts, climate engineers, mechanical engineers, they all have modeling systems, but it's been completely inaccessible to most people. We're about to have desktop modeling and simulation system for us to take our internal mental models, make them tangible, testable, shareable, updatable with other people. And it's not just language models. Language models was the test case of just these transformer architectures. Can you put a ton of words in and get some music? Well, words are interesting, but what we have in these language models is not a word model. It's a model of the descriptions of the world, which is very valuable, especially when you get a trillion words together about that. But they lack dimensions. They lack lived experience. They don't understand things like spatiality and physics. Well, you might have noticed that pretty much all the leading researchers who led the large language revolution have all lost their jobs and have all started world model companies. And what is the world model? World model is not, when you go and look on the websites, if you go into these world labs, what they show you is what looks like a video game that's being generated. That's part of it. Part of it is adding physicality and spatiality in these models, adding modalities. But that's just the tip of the iceberg. Actually, world models are a subset of what I would call systems models. And it makes sense that we're building more models first because humans this is a perfect interface for human beings, right? We're designed to interface with worlds. We understand our brains are designed to interact with spatiality, embodied experience. But world models are going to go way beyond that. These systems are what we call multimodal. That's when ChatGPT suddenly look and create images or sounds. So we're adding these dimensionalities, and that makes sense because our models, when they're multimodal, if I look at this, it looks like coffee, sounds like coffee, smells like coffee, tastes like coffee. Oh, I'm feeling a little, feel it, the jolt. Those are all different modalities. That's how we sense it. not just descriptions. So as we add different layers of modality, not just space and time, physics, but also like social dynamics or scientific data, being combined and triangulate across many, many modalities. And I would argue that we're coming back to the modeling that we all want to do, is that we're going to be modeling ourselves. I don't know if you guys have talked to Claude about your own internal thoughts, but it's been pretty interesting for me. We're going to be modeling social relationships, the world, and also our relationship industry. And of course, this is a double-edged sword. All media, including models, can be used for either truth seeking or truth breaking. We've also seen the kind of AI psychosis of people who have kind of echo chamber, the sycophantic aspects of chatbots. But the other day when I was on Fable, I literally actually had a teared up moment because it gave me some insights about my own work over my entire life. And I just thought, oh wow, like I can imagine if I wasn't happily married, like I could fall in love with this thing. You could see that. But then the next line, it was literally saying like, you know what, you need to go outside. Take a break. This is a good place. So certain models like Anthropic that are attempting to try to actually be helpful to us and not entrap us, at least conceivably. Anyway, I'm just saying this is a double-edged sword. And then, this is all very lofty, but I'll just end on an example. This can be very practical. So a recent model I made, built this with an AI coding tool, was a model for trying to understand when it's worth getting up early to go tide pooling in Pacifica in my house. So I took in a bunch of data, like tide charts, and it actually went on iNaturalist and looked at recent sightings of interesting wildlife in Pacifica. It looked at seasonalities. It also, I told it the days I would be willing to get up early and not. And now it sends me a little bit of an alert, like, okay, it's worth getting up at 5 a.m. to go out Pacifica, because I believe the model assumes that you're going to have a good experience, and boom, we had a pretty darn amazing experience where we got to see nudie brinks, which I don't know if you know, are these incredible sea slugs, just 20 minutes from our house. Anyway, this is an example of modeling, this personal modeling tool that I made in an afternoon, and it's giving a lot of value to my life. And incidentally, I have to say, if you haven't experienced a nudie brink in real life, it will help you expand your cone of possibility. They are preposterous creatures. Like, they just do not look like they should exist. All right, I'm getting long here, but just to wrap things up, a lot of what we think about when we think about technology, especially when powerful forces are coming through, it's hard not to feel a little bit like, okay, how am I going to fit into this machine? How do I fit into this technological world? And one of the things I like to remind people of is that technology isn't just computers and AI models. Technology, it includes social technologies, right? Language is a technology. Governance, technology. Social norms are technology. Court systems are technology. City government is technology. These are all technologies where we have different layers of agency. And I really hope that as we move forward with AI, we imagine not ourselves trapped inside of a machine, but that these systems are inside of being reminded they're inside of our other human technologies, our social technologies, our justice technologies. And just to finish this off with a quote from Alvin Toffler, I was recently reading Future Shock. If you're not familiar with the book, this kind of launched a lot of the modern futures movement in the 1950s. And I hadn't actually ever read it, even though I worked at the Institute for 10 years. But last year I finally read it, and I was shocked to realize that Institute for the Future is in the book. And what a lot of folks think of, what is mostly known for is this idea of future shock. And that the idea that he introduces, and similar to Ray, that change is happening so quickly that the future is coming so quickly. And again, this was in 1960. The future felt like the change was happening so quickly. The future felt like it was happening so quickly that people were in this state of shock, very similar to culture shock, like where it's like, but you can never go home, unless I guess you're MAGA. And a lot of people speak of Toffler and with Ray, he's kind of one of the early futurists. And I think that one of the biggest mistakes people make about Toffler and even Institute for the Future researchers is that, that the future is something that, futurists think about. And, they have some sort of crystal ball or they're just super smart so they can figure out the future. And the reality is actually the future is undetermined and it's actually something that we create collectively. And there's a really great quote I wanted to share to end my talk here from this book. And so he was saying, this was partially inspired by visiting the earliest future. He said, today as never before, we need a multiplicity of visions, dreams, and prophecies. Images of potential tomorrow before we can rationally decide which alternate pathways to choose, which cultural style to pursue. We must first ascertain common possibilities. The application of the imagination to the future thus requires an environment in which it's safe to err, in which novel juxtapositions of ideas can be freely expressed before being critically sifted. We need sanctuaries for social imagination. And actually, the Institute for the Future has taken this up as their official motto. But I would argue we're sitting in one right now. So this is such an honor to be part of this. Getting choked up here. What you guys are doing here is super special. Having this audience here is super special. I appreciate you letting me talk way too long on all this here. I'm going to end here. I'll do my rapid forecasts. Rapid AI adoption is from rapid AI adoption to cautious AI assessment, from autonomous agents to harness augmentation, from language models to world models. The future of AI is multimodal. The future of AI is multimodal. And I would even say the future in general is multiversal. All right, that's my talk. Thank you for bearing with me.